Hello everyone, my name is Dmitry Goncharov. I'm the senior developer at AI Center with MTS. I'll tell you about classification of animal photos captured by photo traps. We cooperate with the national park Leopard Land. It's a big protected area found in Primorsky Krai. The main goal is to preserve and restore the population of Amur leopard. This is the rarest in the world big cat. Poaching, forest fires, and human activity reduced the population to almost extinction. Only 34 cats were left. But the park's work managed to increase this number by 3 times. Last year, we spotted 97 leopards, with 10 new kittens born this year. There are several photo traps in this park that help observe the animals. To study and preserve the leopard, you need to do more work than just the leopard. We should also care about other animals that help preserve the numbers. We should also check for potential competitors. For example, the Amur tiger, another endangered animal, and bears. The photos can also allow to check for other animals like deer, lynx, boars, and other animals. Automatic cameras are installed all over the National Reserve. They capture images of different animals. Analyzing these photos, we can check what routes they have and how many exist there. We receive up to 1 million images per year that used to be sorted manually, and the scientists said that this routine took up to 50% of their work time. The AI implementation will improve the efficiency of this data treatment. Now, what kind of features do we have? First of all, we have different conditions. Photo traps work both day and night, any season, any weather. They only work when a motion detector fires up, but it can also give a false response, like if a leaf moves or if the weather changes. A photo can also contain several types of species. Sometimes it's very high. Some animals like approaching the photo traps, and we see them often. Others almost never venture in. So during our data analysis, we selected 9 classes where trash is pictures without animals, false responses, false alarms. We also chose 6 classes for animals: leopard, tiger, deer, boar, bear, and foxes. We also have another class for animals that we don't have a lot of pictures of, or tiny animals, or animals that are not interesting to us. For example, squirrels, birds, and forest cats. Another class is people. It's mostly the employees of the park who install and service the photo traps. Pictures received can have different distortions as well. They fire automatically, and in some cases we can see distortions such as disturbed lighting or blur. Disturbed lighting makes the whole image very dark, even if there's an animal inside, and it can complicate identification. We often have disturbed lighting from clouds, wrong setup, exposition or bright sky, etc. Night mode photos don't have any colors. And as you can see on the picture on the right, precipitation can add more noise. If animals move quickly, we'll see motion blur. Another characteristic distortion we've received in night mode is noise. You can see it on the left picture. You can see these granules. This is noise. It's usually shown in white dots or spots. Also, night pictures can have noise that look like vertical or horizontal white thin lines. Also, the precipitation can dirty up the lens, which you can see on the picture on the right. This is not fog or anything else. It's some dirt or mud on the lens. Another difficulty is when we have tiny animals in the image. For example, there's a monk on the picture on the left, which is hard to detect. I've seen some other cases with a boar, a tiny boar, that were indistinguishable from ground. The motion sensor can also fire up when a person is close, but there's almost nothing to see. For example, picture on the right. You can only see the tail of the tiger. It's barely in the picture at all. There are other cases too, with only part of a tail, or part of the face, or part of the body. That makes it almost impossible to identify the animal. For those who could not see the chipmunk, that's where it was. By the way, going ahead, I can say that neural networks actually managed successfully to process these two pictures. Now, since there's a limit on computational performance, we're planning to use this neural network on a computer without GPU. So we decided to go for MobileNet v2, pre-trained on ImageNet, open dataset with a standard frame shape. Since there's a long disbalance between classes, we decided to use weighted cross-entropy loss. To achieve higher efficiency, we use strong data augmentation. For example, in the top right corner you see the original image, and you see what the augmentation did to it in a random order on the bottom. Among all the algorithms we use for augmentation, for pre-training, we should note grayscale inversion algorithm. Why do we need it? Because about 30% of images are made in night mode. Without that augmentation, we won't be able to achieve enough accuracy for classification of the images. You can see the examples of how this augmentation changes the image received in day mode and in night mode. In addition to random contrast change, it can increase the accuracy by 8%. This slide shows the test results, the main metrics for each class and the average metrics. For most classes, we've achieved efficiency that can only be improved by post-processing of the results. As for the F-score, for the whole set of test images, it's 0.95. Now, how do we use it? How do we plan to use this neural network? This neural network will increase the speed of processing of images, but they will still use manual validation, because the final result requires 100% accuracy. So that's why we use a post-processing algorithm. Now, when we filter out the predictions with a confidence lower than the threshold, in this case is 0.75, these images can be marked as unknown, an unknown class, or inconfident. The metrics for all images that were classified with a high confidence, above the threshold value, that will increase. And will only filter out a small amount of images, up to 3.5%. They mostly filter cases that make it hard or almost impossible to classify an image. For example, strong distortion, or when there's only a part of an animal that makes the identification impossible. Now, conclusion. Thanks to that solution, scientists can now spend more time on important stuff, get rid of routine. The neural network can allow to process a year worth of data in several hours. The scientists are now using that solution, and they want to create an extended version to increase efficiency of identification and to also recognize some other types of animals. That's it. Thank you for your attention.